So let's go over statistical tests, and in this class we're going to start with a G-test. How do we use the G-test? What is its work? So the first thing we need to know is that when you are performing measurements, many times you are going to have some errors, obviously because of us being human, and those mistakes, some of them are unavoidable. We need to know in statistics or in analytical chemistry, you have got some errors that you can avoid. You call them determinant errors. You also have some errors that you can't avoid. You call them indeterminate errors. The determinant errors are as well referred to as systemic errors. So the problem is either you are not trained enough, or the instrument that you are using is not well calibrated. So such errors are determined. You can determine them. They are determinable. So we call them systemic errors. But indeterminable errors, which we call also as random errors, you can't determine them. For example, because there is a change in environmental temperature that affects your reading of your values that you are dealing with. So you can't change that. So let's say here is our titration experiment. Here we have got our titrant, and we have got our analyte here. You know, the analyte is the compound or substance that you are trying to be able to measure, isn't it? So when we start polling our titrant, because in the analyte we have also put an indicator, as we start polling our titrant, the color will start changing. Let's say the color changed when you poured a titrant, let's say of 2 mils, and then you did it for the second time, the color changed at 2.01 mils, and then you did it for another time. Now this burette might not pick such a small change. Let's say the change was at 2.1. You did it for a third time. Let's say change was 2.2 mils. You did it another time. Let's say you found 3 mils. So you see, of all these values, 2.1, 2.2, they are very close to each other. 3 is a bit far away. So this 3 is going to be an outlier because it is away from the others. Let's say I've written a test. Everyone has gotten 40%. Someone ends up getting 95. So this one is an outlier. So the G-test is going to be able to identify whether the outlier is going to be rejected or it is going to be retained. So you are just identifying, is this outlier too much away from the normal, or we can accept it. Some things I want us to understand before we look at the some calculations with the G-test is when you're dealing with a sample and a population. You know, a population is the entire group that you are dealing with. Let's say you count people in a certain environment and they're 100. That is the population. Now, when you're trying to perform an experiment or carry out a certain procedure, you might not use the entire population because these are a lot. It will cost you a lot of money. And so what you want to do is you just want to get a sample from the 100. And let's say you just get 5. And these 5 that you've gotten should be a representation of the entire 100. So you call it a representative sample. So when you are dealing with samples and populations in statistics, they are going to have different representations. For example, the mean. When you're talking about the sample mean, you use, for samples, you always use English letters. Populations, you are going to use Greek letters. So sample mean, you are going to use X with a bar on top. But population mean, you are going to use mu. Okay. And then same with standard deviation. So standard deviation. For the sample standard deviation, you use S. For the population standard deviation, you use sigma. You also have variance. Variance is the square of the standard deviation. So here you use S squared, here you use sigma squared. Now, formulas again, which we need to know. For the mean again, for the sample mean, we are going to get the sum of all the values that we have, all the values. So we'll call them x. I'll put xi there. That's what we use for each value. And then you divide by how many there are. For sample, you want to use a small n. And then for population, you still get the sum of all the values, but you divide by how many there are. You use capital N because it's the entire population. And then for standard deviation, for a sample, what you do is you get a square root of the summation. You are going to get each value. So you get a value x1, you remove the mean, and then you square that. Down, you are going to divide by n minus 1. So let's say, for example, you had a sample of size 5. So it will be 5 minus 1. But for a population, you are going to get the square root of the summation of each term. You are going to remove the mean, you square that, and sorry, the mean here we said we are using mu, right? And then you divide by n instead of n minus 1. So it is important for you to understand whether you are dealing with a sample or with a population. But majority of the things we'll be dealing with in statistics will be a sample because we don't have time to get the entire population and resources as case. So for variancy, just remove the square root because you are going to be squaring. So the square and the square root will cancel out. Okay, so basically that is what we do. So let's consider a question here. For the following data set, determine whether the outlier will be accepted or rejected at 95% confidence. So what is the first thing that we want to do for a G-test? The first thing is you want to determine the mean. And this is going to be a sample, as we said, not the entire population. So sample mean is going to be equal to, you get the sum of all the values, you divide by how many they are. So here we have got 29.8 plus 29.9 plus 29.7 plus 29.1 and then plus 27.4. You divide by how many there are. How many are these values? 1, 2, 3, 4, 5. So there are 5. And when you get to punch this on your calculator, you are going to get on top first the sum will be 145.9, and this is over 5. And when you divide, you are going to get 29.18. When you find the mean, the next thing you want to find is the sample standard deviation. Remember, we said you are going to use S. And this is given by what? The square root of the summation of each term minus the mean. So this is xi minus the mean. You square that and then you divide by n minus 1. This is going to be the first term is 29.8. Remove the mean, which is 29.18. You're supposed to square this plus the second term here is 29.9. Remove the mean, which is 29.18. Square that. The third one is 29.7. Remove the mean again, 29.18. Square that. And then the last one is 27.4 minus 29.18. Also square that. You want to divide everything by n minus 1. So n is 5. These terms are 5. So 5 minus 1, that would be a 4. And then you want to take the square root of that. So when you get to punch this on the calculator, 29.29 squared minus 29.18 squared plus everything like that. On top, first is going to give you 4.348, and then that will be divided by 4, and then that will be square root. If you punch this, you are going to get the square root of 1.087 when you divide 4 into 4.348. And when you find that, you are going to get 1.0426. So now that we have got the standard deviation and the mean, can I now remove this so that we can have some space? Don't forget the value that we have found for the mean, because that's what we are going to be able to use. And at this point now, you need to know the formula that we use when you are determining, when you are dealing with the g-test. So I'm going to write the standard deviation and the mean just on top here. So what mean did we find? Found 29.18, and the standard deviation is 1.0426. So we have got what we call G calculated. So we are going to calculate the G value. Remember, this is a G test. So we have got G calculated, the one that we are calculating. And G calculated is given by the absolute value of the outlier. You remove the mean, and then you divide by the standard deviation. So the outlier that we are dealing with here is 27.4. The mean is 29.18, and then you divide by the standard deviation, 1.0426. We are taking the absolute value because we are not interested in the sign. Otherwise, if you subtract 27.4 minus 29, you're going to get a negative number. But just discard that negative and then divide by 1.04, and that is going to give us 1.707. So this is the G calculated. Another value that you want to determine is what we call G tabulated. So the G tabulated, you are going to get it on the G test table because this is tabulated. And on the G test table, it will be provided. So you can see this is a G test table. What you want to know is first the number of items that you have and at what confidence are you dealing with. So we're dealing with 95% confidence. Our n, how many values do we have? We have got 5 values, and then the confidence is 95%. So we go now on the table. 95% is equivalent to 0.05 when you see that. So 0.05 is here, that is our confidence. And then our values is 5. So look at the value that we are finding. That is 1.67. Okay. So that is our G tabulated, 1.67. So now you want to compare the value, the G tabulated and the G calculated. So we'll say G calculated and then G tabulated. Which one is bigger than the other? Calculated is 1.70. Calculated is 1.6. So the calculated is greater than the tabulated. So we'll say this. G calculated is greater than G tabulated. Every time what you have calculated is bigger than what is on the table, it means that there is a significant difference and that value is going to be rejected. So therefore, this outlier is, there is a significant difference between the outlier and the other values. Therefore, we're going to reject the outlier. So that is how we deal with this. Thank you so much for watching. So if the opposite was true, if G calculated was smaller than G tabulated, we would have retained the value. We shouldn't have rejected it. We would have accepted it. And that is it for this class. In the next class, we're going to talk about the Q test. Please don't forget to subscribe and stay blessed.